Swayam Prabha, free DTH channel for education.
The last lecture, okay, the last lecture in this course. So we are going to wind up almost whatever we have done so far. Okay, so we started with the ordinary differential equation. Okay, first actually we started with the mathematical modeling and then cancer treatment model, etc. Later we moved to the heat equation, derivation, etc. And then we moved to ordinary differential equation. We solved many of the problems, including first order ODE and second order linear ODE, and then constant coefficient, and then we moved to the variable coefficients, etc. And we have found the Frobenius series method and other methods also. So now we are almost going to end this lecture today. Okay, so two more topics are there, so I'll just complete it. So some of them I will just I have already solved it and then kept it in the website, so you can refer that for the last one. So the remaining thing I will just solve. Okay, so what we are going to do is that we are going to solve the wave equation in Cartesian coordinates, okay, which is double Fourier series, which is going to result in a double. We are going to use the double Fourier series, okay, which we have not discussed so far, the double Fourier series, but here they are going to highlight a small piece of information for you. So let's start with that. So what we have is we have the wave equation, okay, the wave equation which we are going to solve it in the Cartesian coordinates, okay, in two dimensions. So what I'm going to do is that I'm going to solve this problem. Ut is equal to c square uxx plus uyy. Okay. So this is a problem I'm going to solve. I'm going to solve in a small rectangle only once again. Okay, I'm going to solve it here in this rectangle, 0, a and 0, b. Okay, so take a piece of paper and then like you can just say like this is a drum or some kind of piece of information is there. Okay, so where you are going to disturb so that it is going to oscillate up and down. Okay, so that's what we are going to solve now. And conditions given here is that we have the conditions like u equal to 0. Okay, means everywhere. Here also it is 0, equal to 0, equal to 0 here, equal to 0 here, equal to 0 here. Means on the boundary. On the boundary, I have u equal to 0 on all boundary. In all boundary. So means it is a Dirichlet. Okay, this is a Dirichlet problem. Then I have initial condition. So the initial conditions are like u of x comma y comma 0 equal to, let's say, f of x comma y. Okay, since it is a two variables are there, I have, and ut of x comma y equal to 0 equal to g of x comma y. So that means I have initial displacement is f of x comma y and initial velocity is x comma g of x comma y. Okay, so these are the information given. Now what we need to do is that we need to solve this on this numbering 0 comma a cross 0 comma b. We are trying to solve this problem. So once again, what we are going to do is that for this problem, we are going to assume that u of x comma y comma t equal to, we are going to assume that it is going to become like f of x comma y. I'm going to separate that x comma y separately, and then g of g I'm going to separate it separately. So this is the separation of variable I'm going to use it. Now what I am going to do, again I can use that same kind of information. So utt is going to become like, you can see that f of x comma y into g double dash is going to come, okay, and uxx is going to become like fxx x comma y into g is going to come, and uyy is going to become like fyy into g is going to come, okay, fyy into g is going to come. Therefore, that equation is going to become like utt plus c square uxxy is going to become like, I'm going to get f into g double dot equal to c square into fxx plus fyy is going to come into g. Okay, g is common, so I'm just writing g. So therefore, what we are going to get, you are going to get, you are going, once again, you can just use the variables of purpose. So you are going to get g double dash divided by c square g equal to 1 by f into fx x plus fyy is going to come. Again, I'm going to use the same logic, put that variables, etc. It is going to come. So I'm straight away going to the last case only. So it is going to be like minus mu square. I'm just assuming it at. Okay. So the remaining are going to become like nu equal to 0, nu equal to lambda equal to mu square. Whatever you are taking, that is going to become like you are not going to get that. Only this is going to survive. Okay. So same kind of logic you can use. So therefore, you are going to get two equations now. Actually, we will get three equations. Okay, we will see. So g double dot plus mu square g c square mu square g equal to 0. First equation. Equation number 2 is you have now fxx plus fyy. Okay, plus mu square f equal to 0 is there. Okay. So plus mu square f is there. So we need to do something similar. So this equation is called Helmholtz equation. Okay, this is not Laplace. It is called Helmholtz equation. This equation is called Helmholtz equation. Okay, so this operator is Laplace operator, but this entire equation is called Helmholtz equation because you don't have the equal to 0 or equal to some function of. So it is not Laplace. It is not Poisson, but this time is Laplace operator. So we are going to have Helmholtz equation for this one. So now what we are going to do, we are going to solve the Helmholtz equation first and then we are going to get that. So once again I am going to use, okay, fxx, fyy is there. Now what I am going to do is that f of x comma y also I am going to split it into two terms. One is h of x into q of y, okay, h of x into q of y. Therefore once again you can do the same kind of job. Okay, so fxx is going to become like h double dash is going to come h double dash into q, and fyy is going to become like h into q double dash is going to come. Okay, again you can use this logics, etc. Okay, so therefore what you are going to get is that you are going to get this equation. Okay, you are going to get two equations from here. So let me say 2a. So 2a is going to become like, you can apply that. You are going to get 1 by h square. Sorry, 1 by h. Okay, 1 by h into d square h by dx square is going to come. Okay, equal to minus 1 by q. So this just going to write that equation only straight away. Okay, so we'll come to this. So here this is going to become like, if we substitute it over here, fxx plus fyy equal plus mu square f, what it is going to become? It is going to become like h double dash q plus hq double dash plus mu square into hq equal to 0 is going to be there. So once again divide everywhere by hq. Okay, so you can assume that it is again the same logic whatever we used for the wave equation and heat equation. If one of them is going to become 0, then the trivial solution is going to come. We are not interested, etc. So therefore it is going to become like, we are going to get h double dash by h plus q double dash by q plus mu square equal to 0 is going to come. Okay, so this is the one which you are going to get. So we are going to solve this problem. Again, you are going to write this as, okay, equal to, you are going to keep. Okay, so I'm going to write it like I'm going to write it in this way. So I'm going to put equal to here, okay, and then minus here, and I'm going to take 1 by q out here. Okay, minus 1 by q. Therefore, this is going to become like q double dash plus mu square q equal to 0 is going to come. Okay, so equal to sorry, not equal to q. So this is this is a constant term. This is a constant term. So again, you can use the same logic. So you are going to get minus k square is going to come. So therefore, you can just simplify this again. Okay, so you are going to get this equation. 1 by h into 1 by h into d square h is there. So I'm going to write this as d square h by dx square. Substitute over there. Therefore, this is going to become like k square h is going to come. Similarly, equal to 0. Similarly, 2b. Equation 2b is going to become like, use that one. Okay, substitute over there and then bring it over here. I'll come to this boundary condition in a short period. So you're going to get this one. Okay, d square q by 2b is nothing but d square q by dy square. Okay, plus p square q. I'm going to use it. Okay, where p square is nothing but nu square minus k square. Okay, where nu square is coming from here, this nu square is there, and putting it over there. Therefore, this is going to become like minus is going to come. I'm just bringing this minus also over there. Therefore, this is going to become like d square q by dy square plus d square q equal to 0 is there. So you can just see here minus 1 by q, q double dash plus nu square q is going to become like k square is going to come. Okay, k square is going to come. So I'm going to bring this q over here. Therefore, this is going to come. So therefore, I'm going to get q double dash plus nu square minus q square minus k square, nu square minus k square, q equal to 0 is going to come. That's what I'm writing here. That I'm calling this nu square minus k square. This term I'm going to call it as p square. So that's what I have. So therefore I have now three equations. One is g double dash plus u square g. Second is this one, and third is this one. So you have three equations. Now if you come to the boundary condition, once again you can do the same logic. Okay. So you have f of x comma y equal to h of x into p of y is there. So in this case I can use the same kind of logic. What I can use that on the boundary I can apply that. So if I apply on the boundary, you are going to get h of u equal to 0 here. Therefore you are going to get h of 0 into q of y equal to 0 is going to come because u equal to 0 there. Therefore, what you are going to get is that you are going to get qy not equal to 0. Therefore, you are going to get h equal to 0 is going to come. Okay. Similarly, if you put h of a into q of y, again same logic you can use. So you are going to get h of a is also 0. Same logic for the qy also. So you are going to get h a equal to 0. H of 0 is 0. H of a is 0. Q of 0 is 0. Q of b is 0. So you have four equations here. Four derivatives are here. Here two derivatives are there. Here two derivatives are there. Therefore, you are going to have at least four boundary conditions are required in order to solve this problem. Okay, you have already four conditions. So these four conditions we are going to use it to solve this problem. So if I solve this problem, first let me solve this problem. Okay, so let's solve 2a. If I solve 2a, what I am going to get? I am going to get. You are going to get h equal to k into k. You can see that m square equal to plus or minus k is going to come. Therefore, your h of x is going to become like a cos kx plus b sin kx is going to come. Okay. Now, similarly, 2b, if you solve the 2b, okay. So for 2b, same kind of thing. So you are going to get q of y is going to become like let me put some other variable. So c cos py plus d cos d sin py is going to come. Okay, where p is nothing but nu square in this case. So therefore, your f of x comma y is going to become like, okay, your f of x comma y is going to become like a cos kx, c cos py, etc. is going to come. Now, some of them are like you are going to use the boundary conditions. Okay, once you are using the boundary condition, so you have this boundary condition. So for this one, I have h of a equal to 0, h of 0 equal to 0. Okay, and for this one I have q of 0 equal to q of b equal to 0. Okay, so this boundary condition I don't use it and then bring it down. Okay, so you are going to get only one term is going to survive, remaining time is going to vanish. So in that case, again we are going to get, if you are using q of 0 equal to 0, that is going to become like a equal to 0 is going to come, and q of a equal to 0, sorry, h of a equal to 0 if you are using, then you are going to get only b sin k a is going to become 0. Okay, so therefore sin k you can take, and then you are going to get k is going to become like n pi by a is going to come, or I'm just using different notation here. Okay, m I can't use it. So in this case, if you use this boundary condition, then you are going to get h of x equal to, you are going to get only b m into sin m pi x by a is going to come. Okay. So I'm going to conveniently, I'm going to assume that this is 1. Okay, so that at the end we can use the linear constant. Even if it is not 1 also, we can absorb it in the constant terms. Same way, we are going to get q1 of y is going to become like sin, I'm going to use some other notation, n pi y by b I'm going to use. So these are the things which is going to apply. Where m comma n equal to 1, 2. So in this case, what you are going to get is that you are going to you are having two indices. So therefore, fmn of x comma y is going to come, which is nothing but hm of x into q1 of y. That is going to become like sin m pi x by a sin n pi y by b is going to come. Okay. Therefore, this is your fmn of x comma y. Now, what is your what I'm going to do is that I'm going to find my lambda. The lambda is nothing but we have this one cd. This is I'm going to call it as lambda. Okay, so lambda equal to c nu. Okay, lambda equal to c nu. Lambda equal to c nu. Okay, c into nu is nothing but you can bring it from here. It is nothing but p square plus k square is going to come, or k square plus p square. Okay, therefore this is going to become like square root of p square plus k square I can write it, or k square plus p square I can write it. Where here you can see that this is nothing but km is going to come, km is nothing but m pi by a is going to come. Here it is nothing but p is nothing but n pi by b is going to come. Okay, so therefore you can substitute it over here. So you are going to get it like you are going to get pi. I can take it out. Okay, if I take pi out, this is going to become like c into pi into square root of these two terms. So m square by a square is there, plus n square by b square is. This is going to be your lambda, and this is going to be your eigen values for this problem. Okay, so you can see that two values are variable. It is depending on two variables. Okay, one is m and n. Okay, so you are going to I'm going to call this as instead of lambda, I'm going to call this lambda m n. Okay, so for each integer m, for each parameter m comma n, always you can find these values. So this is going to be used in our problem. Okay, so in that case, what you are going to get? You are going to get again. This is once again c square v square g. Therefore, for this problem, what you are going to get? You are going to get the answer for this one, which is going to be in terms of mn. So gmn t is going to become like once again a cos lambda m n t plus b sin lambda mn t is going to come. Okay, so this is going to be the solution. Therefore, what you are going to get? You are going to get your original solution, which is nothing but here. Okay, so this one, this is going to become like once again umn of x comma y comma t is going to become like, I have to substitute this one. Therefore, this is going to become like a cos lambda mn t plus b sin lambda mn t. Okay, so I'm going to put here also since it is involving m and n, so here also I can keep it like mn. Okay, bmn and c amn. So this is going to become like amn, and this is going to become like bmn. Okay, into sin lambda mt, and I have to multiply this one kachem of x and qn of y. So kachem of x and qn of y is nothing but sin m pi x by a and sin n pi y by b. So this is my eigen functions for the wave equation. Okay, this is nothing but the eigen functions for this wave equation in two-dimensional 2D variable with Cartesian coordinates. For the eigen values lambda m. Okay, lambda m are called the eigen values. So once again, what you can do is that here you have double indices. Since you have double indices, what you are going to get is that you are going to get I will erase the rest. Okay, so you are going to have double Fourier series here. Since you have double indices, what you can do is that you can obtain this one. So u of x comma y comma t, I can write it as summation double summation m equal to 1 to n, or you can just change that, not a problem. M equal to 1 or m equal to 1. So m equal to 1 to infinity and n equal to 1 to infinity. Okay. So this is going to become like, I can use this one. So this is going to become like u mn of x comma y comma t. So that is going to become like summation m equal to 1 to infinity, summation n equal to 1 to infinity. Okay, this is going to become like a mn cos lambda mn t plus b mn sin lambda mn t into, I have to use this condition. Okay, remember this one, into sin m pi x by a sin n pi y by b. So I have two conditions still unused. One is x comma y comma 0 equal to f of x comma y. Okay, another is ut of x comma y comma 0 equal to g of x comma y. So these two conditions I haven't used. So this condition I am going to use it now. Okay, so now what I am going to do, I am going to use the first condition. So you are going to get v of x comma y comma 0 is going to become like summation, which is going to be f of x comma y. Okay, f of x comma y equal to summation m equal to 1 to infinity, summation n equal to 1 to infinity. So I am putting t equal to 0, therefore this is going to vanish. So you are going to get this is going to vanish. So the amn is going to be there. Amn into sin m pi x by a into sin n pi y by b is there. Okay, sin n pi y by b is there. So this one, this is called double Fourier series. Okay, this series is called double Fourier series. So how do we obtain the answer for this one? First, what you can do is that you can just obtain the km of y. You can obtain. Okay, km of y. How do we obtain is that I integrate this one with respect to y variable. Therefore, only one is going to come. Only one. This one of the series is going to vanish. Okay, only one term is going to survive. Remaining is going to be there. So the inner series may be there. Outer series will be having only one term is going to come. Okay. Now then calculate again. Okay, so therefore you are going to get km of y is going to come. Now for this km of y, once again do the same kind of thing. Okay, this km of y is going to become like you are going to get summation m equal to 1 to infinity something into, okay, some term is going to be there. Okay, some term into you are going to get amn into sin n pi x by a is going to come. Okay. Now once again use the same. Okay, you use this one km of y. Again apply the sin m pi x. So in that case, this is also going to become like survive only at m equal to when here and here same. Okay, only m pi x term is going to survive. So in that case, what you are going to get is that you are going to get something like amn is going to become like multiplying over here. Therefore, in general, what you can write is that you can write like amn equal to 1 by, okay, so this is going to become like you are going to get this one. Okay, amn is going to be applied. So how do you apply? So let us see that. So this is the one which you are going to get. So for first one you will get 2 by a. Okay, if I am just removing this one, 2 by a will come. Again I am going to use this for here. So again I will get 1 by another 2 by a. Therefore this is going to become like 2 by b will come. Okay, 4 by a b will come. Okay, a and b are different. So you will get 4 by a and 2 by a and 2 by b is going to come. Therefore 4 by a b is going to come. And this is integral from 0 to a, 0 to b. Okay, so you are going to get f of x comma y sin m pi x by a. Same logic, whatever we used, okay, the same logic you are going to use, and then you are going to get this one. So this is going to be your Fourier. This is Fourier sine series. Okay, so double Fourier series actually. Okay, so with the sine terms only, and your amn is going to be this one. Now you can apply the same logic for the other one. Okay, so in that case you are going to get bmn. So bmn is also going to come. It is going to be coming like 1 by. So here one more term will cancel. So you are going to get 1 by ab into lambda m1 is going to come. Okay, lambda m1 will come because once you are differentiating, there is a lambda m1 is going to come. Okay, so therefore you are going to get here 0 to a, 0 to b, g of x comma y into same thing sin m pi x by a and sin n by y is going to come. So this is called double series, and we are using this one to find the answer for the wave equation. So this is called wave equation solution using double Fourier series. Okay. Fine. So here dx dy, those are all just as usual you can put. So you can take this problem and then solve it. Okay, f of x y equal to 0.14 x minus x squared 2y minus y square. So you can substitute it here and then you can find the Fourier series for this one, and then you can calculate your amns and bmns, and then you can solve the problem. Okay. So initial displacement and initial velocity is given. So initial displacement is 0.4 into 4x minus x squared 2y minus y square. Initial velocity is 0.1 into x. So same way you can solve this one. Okay. You can substitute and then solve this. Okay. Similarly, okay, one more equation is there. So instead of 0 comma a, I have taken 0 comma pi and 0 comma pi. Okay, means square plate I have taken. Okay, where the edges are kept at 0 degrees Celsius. Means everywhere it is 0. Okay, all the edges are 0 degrees Celsius and faces perfectly insulated. Okay, so again the heat equation in 2D, which you can give in the similar way. Okay, so here what I'm going to do is that a similar kind of one. I'm going to do it in the heat equation here. Instead of wave equation, it's going to be the heat equation. So in heat equation, this term will not be there. Okay, this is due to the wave equation. You are going to get amn cos lambda n, bmn sin lambda n is going to come. Whereas if you use the heat equation, so in that case only t dash only will come. So if it is t dash, you are not going to get cos and sin is going to come. It's going to become the e power is going to come. So e power minus e square m square n square is going to come in this case. And then you can solve this problem. Again, you can get the similar kind of answer. Okay. So this one, same way, only change is that instead of these two terms, you are going to get only one term. Okay, that is the heat equation. Okay, this is also a simple one, so I am just leaving it as an exercise to you. Next one, this is the Laplace equation in spherical coordinates. Okay, again I am going to leave. I have given the solution already. Okay, how to obtain the solution for this one means how to derive this one. As we did in the morning polar coordinates, we can do the same thing for the spherical coordinates also. These spherical coordinates, we are going to have three variables are going to be there. Okay, one is two variables are similar to polar coordinate, but with another term called pi term is going to be there. So that pi term we are going to use it for solving this problem. Okay, so this is going to become like a spherical coordinate problem. So you can use u equal to r. Sorry, you are going to solve this problem. Okay, uxx plus uyy plus uzz equal to 0. This is the problem we are going to solve. Okay, so in this case, I am going to use the spherical coordinate. So that I am going to use x equal to r cos theta sin cos pi, sin pi. Okay, and y equal to r cos theta cos pi or r sin theta sin pi. No problem. Okay, so some of the books use the sin and cos interchangeably, so you should be careful with that. What are you using? And this is going to be like r cos. Okay. In some of the books they use this one, x equal to r cos theta, okay, and then sin pi, and y equal to r cos theta, and then cos pi, and then z equal to r sin theta. So these are also used in some of the books. So we can just use one of the things and then you can do that. Okay, so there are, you can just use some of them and then you can do it. So let's forget about this one. So we use this one. So x equal to r cos theta sin pi, y equal to r sin theta sin pi, and z equal to r cos pi. So this is the transformation given. So in this case, what you need to do is that similar kind of things you need to do. So that is given in my notes. Okay, you can refer that. I have uploaded already. So what you need to do is that you have to find your x ux first. So ux is going to be like ux into xr plus uy into yr plus uz into zr is going to come. Okay. Similarly, so this is ur. Okay, ur is going to become like ux into xr, uy into yr plus uz into zr. Similarly, you can find urr, that is going to become like ux into xr square. Okay, uxx into xr square plus ux into we are going to use ux y into xr yr is going to come. Okay, plus ux z into xr into zr is going to come, and then you are going to have almost 9 terms will come, I think. Okay, so uxy etc. And similarly here we will have uxy uy into yr is there, so this is going to become like 2 times. Okay, and then here also 2 times will come, and then plus you are going to have yz is also there, that is also will come like 2 yz into yr into zr is going to come, plus now we are going to do the other variables. So that is going to come like you are going to have uyy into yr square is going to come. Okay. Similarly, uz into zr square is going to come. Plus you are going to get other terms like ux into xrr is going to come. Here uy into then uy into yrr is going to come, and then uz into zrr is going to come. Same way, you can just do the same thing for theta and pi. Okay, and then if you simplify that, what you are going to get is that you are going to get this equation. So your equation is going to become like, after simplification, you can refer my detailed notes. Okay, so this is equation is going to be like urr plus 2 by r into ur. Okay, so plus 1 by r square into u theta. Okay, plus sorry pi theta pi u pi plus cot pi by r square, okay, into u pi, okay, plus you are going to get 1 by r square sin square pi into u theta equal to 0. So this is your Laplace equation in spherical coordinates. Okay. So I'm not going to derive this, it is already there in the notes, so you can do it. Same thing what we did in the morning. Okay, if I derive this one, it's consume my whole time. So I'm not going to derive that. So you can just refer the notes which I have uploaded already. Okay, this question I have asked in the 2 years before I asked the exam also, the same question. And only 1 or 2 students have solved it. Okay. Now what we are going to do is that we can rewrite this equation in another format also. Okay, what I can do is that I can rewrite this equation. So this 1 by r square, okay, 1 by r square, you can just verify this one also. Dou by dou r of, okay, r square into dou u by dou r. You can just verify that. Okay, this is going to be these two terms. So you can just check that dou by dou r of r square dou u by dou r is going to become like we are going to get 2r into dou u by dou r is going to come. Okay, first term 2r into dou u by dou r is going to come. 1 by r square is outside already. Okay, plus again you have to do that. So we are going to get r square into dou square u by dou r square is going to come. So you can verify that if I substitute, if I multiply by r square, this is going to become 2 by r into dou u by dou r, and r square cancels. You are going to get dou square u by dou r square. So now I can do the same thing. Okay, the remaining things also. So I can take this cot pi I can take out. Okay, so that is going to become like I can write it as. So this one similarly we can do this cot pi term, cot pi u pi and u pi beta. Same way you can do. What you will get is that you will get that 1 by sin pi into sin pi. Okay, this is sin pi dou u by dou pi. I think one more is missing there. I think dou by dou pi will come. Okay, so there is a missing there. So it should be 1 by sin pi dou by dou pi of sin pi dou u by dou pi should come. Okay, there is a dou by dou pi is missing there. So you can see that once again this one. Okay, if I take this dou by dou pi, this is going to become like cos pi. Okay, into dou u by dou pi plus sin pi into dou square u by dou pi square is going to come. Outside there is a sin pi is there. Okay, so 1 by r square I have already taken out. So this is going to become like cos pi sin pi is going to become like cot pi into u pi is there. Okay, 1 by r square is outside. So cot pi into cot pi by r square is going to come. Similarly, sin pi cancels. So we are going to get 1 by r square outside. Therefore, 1 by r square into u pi is going to come. Okay, this is going to be done. Okay, so here also. So I have started here. Then I have remaining term. Okay, that is nothing but I can just take r square outside. That is going to make 1 by sin square pi into u theta theta is. I didn't put anything, any conditions out. This is going to be the another format of the Laplace equation in spherical coordinates. Okay, so there is a small mistake there. Dou by dou pi should be there. Okay, dou by dou pi of sin pi dou u by dou pi should be there. That's one mistake is there. So the rest are fine. Okay, 2r is going to be there. Now you can write this one. Okay, or you can write this the same way which I have given. So the same thing. Now what I'm going to do, I'm going to solve. I'm going again as we did in the Laplace equation in polar coordinates. We assume one of the variable is 0. Here also we are going to assume the same variable u theta theta. I'm going to assume 0 here also. In this problem also we are going to solve this particular problem. When u theta theta equal to 0, what is the solution is going to? That's what we are going to do. Okay, so let us solve this problem. What we are going to solve is that we are going to solve. So this term I'm going to forget. Okay, this term is going to vanish. So I'm just going to assume that is 0. So this is the equation I'm going to solve. Okay. So I have equations. So cot pi into u pi is there equal to 0 is there. Okay. So this is my equation. And then I have conditions. Okay, the conditions are I have the conditions like u of r comma pi, u of r comma pi equal to f of pi. Okay, means we have a cylinder. So we have a sphere. Okay, we have a sphere. In that sphere, we have on the surface of the sphere we have the potential. We can say the pi. The electrical engineering is called as potential equation for this one. So in that case, you can solve this problem. Okay, so you are going to get this one. And then we have another condition: limit r tends to infinity. Okay, u of r comma pi equal to 0 is going to be. So these are the two conditions given, and you need to solve this. So once again, what you are going to do is that you are going to use the variable separate method. Use u of r comma pi equal to h of r into okay, g of r into h of I am use same thing I use. G of r into h of I you are going to use it. Okay. So once again, you can get substitute it over here. Okay, you can use it in this equation. Okay, so you are going to get equation of this kind. So you are going to get g double dash etc. is going to come. Okay, g double dash of r, h double dash of pi, and h dash of r etc. is going to come. So you can substitute it over here. So what you will get is that you are going to get this equation as follows. So 1 by g into, okay, the same way what we did in the morning, the same way you are going to get 1 by g into d by dr of r square into dg by dr is going to come. This is going to be your equation. Okay, and then that is equal to, again you substitute in the pi terms also. So on the right hand side you are going to get minus 1 by h into sine pi. Okay, d by t pi of, okay, t by t pi of sine pi into th by t pi is equal to, okay, sine pi into th by t pi is equal to, again some constant is going to come. Let's say k. Okay, again you don't use these cases positive, negative, equal to 0, all the cases you have to discuss. Okay, so after discussion you get you're going to get this solution is going to come. Here we are going to solve some particular cases, peculiar cases only we are going to solve. Okay, some of the special cases we solve. So what are the equations I'm going to get here? So this is going to become like, I'm going to get r square g double dash. Okay, I'm just differentiating this one, r square g double dash plus I'm going to get 2r g is going to come. So 2r g dash is going to come. Okay, and then I'm substituting over that. So multiplying, so I'm going to get kg equal to, so r square g double dash 2r g dash. Okay, and multiplying here, so minus kg square. So similarly, you can we will solve the other one also. This is equation number 1 is going to come, and equation number 2 is going to become like, I can just use that one. So that is going to become like, I can just bring that k this and multiply by minus throat. So you are going to get 1 by h into sine pi. This is second problem. T by t pi of sine pi into th by t pi. Okay, so I'm just going to multiply by k. So I'm going to remove this k h. Sorry, h. I'm going to remove it from here and multiply that. So therefore, this is going to be kh equal to 0. So again, I have two equations. Okay, so I can solve particular case for this one. So the particular cases I am going to put k equal to n into n plus 1. Okay, so I'm just going to solve only some particular k. So k I am just assuming n into n plus 1. Okay, I'm just going to solve some particular cases only. Okay, I'm not going to solve all the cases. So you can take the other cases also, and then you can solve. There are advanced texts are available, advanced books are available to solve that. I'm just going to take only this case. Okay, so k equal to n into n plus 1. Then that is what we are going to get is that you are going to get the first equation I'm going to solve. So the first equation is nothing but, this is nothing but the Euler equation. Okay, in the place of r square, think of x square. So this is something similar to x square y double dash plus 2x y dash plus minus k into g. So k I am assuming n. So n into n plus 1 into y equal to 0 is going to come. So you know this solution for this one. Okay, this is Euler equation. So for Euler equation, this is the auxiliary equation is going to make m square a minus 1. So a is 2 here. Therefore, you are going to get m. Okay, so m minus n minus n square minus n is going to come. Okay, equal to 0. Therefore, you can take it like m square minus n square plus m minus n equal to 0. So this I can write as m minus n into m plus n in plus m minus n is going to be there equal to 0. So I can take m minus n outside, that is going to become like m plus 1 is going to come equal to 0. Therefore, m equal to n is one root and m equal to minus n is another root. So m1 equal to n and m2 equal to minus n minus 1 is. Therefore, your equation you can just see here. Here it is going to become like y equal to x power n is one root, y1 is nothing but y2 is going to become like 1 by x power n plus 1 is going to be the root. Now same thing, this is Euler Cauchy equation. So if you apply it over here, here it is going to become like you are going to get g is equal to a 1g, you are going to get gn of r is going to become like you are going to get some a into r power n is going to come. Another gn, okay, I'm just going to call it as gn star. So that is going to become like a by rn plus 1 is going to. Okay, two equations are there. Okay, so two equations are there. Now you got the answers for this one. So therefore, what you are going to get, you are going to get the next you need to solve this problem. Okay, the second problem. In the second problem, what I'm going to do is that I'm going to use this again the same k equal to n plus n into n plus 1. So in this case, what you can do is that you can put one more substitution. Okay, if you put the substitution w equal to cos pi. Okay, if you put w equal to cos pi and then simplify this equation. If you simplify, okay, you can put you can calculate what is the tw by t pi. Okay, and then you can substitute over there. So in this case, what you are going to get is that you are going to get the answer as, okay, you are going to get in terms of w, you are going to get t by dw of 1 minus w square, okay, into tw by d th by w, okay, th by tw, okay, plus we are going to get plus n into n plus 1 into h is going to be equal to 0. So this equation you know already. Okay, this equation is called Legendre's equation. Okay, this is called Legendre's equation. Okay, so for this you know the solution. The solution is something but Pn of W is going to come. Okay, but I have kept already for W equal cos phi. Therefore, your question of phi is going to become like Pn of cos phi is going to be the solution. Okay, so this actually I have given on exercise to prove that this equation is same as this equation, which is given as an exercise for the Legendre equation. So that also you can verify that. Okay, so therefore this Pn is the Legendre polynomial. So therefore, what you are going to get is that you are going to get your general solution. The general solution is going to become like so I can write actually I can find the eigenfunction. The eigenfunction is going to become like P1 of r comma pi is going to become like g of r into h of phi. Therefore, it is going to become like I will get two things. Okay, one is going to be a into r power n into Pn of cos phi is going to come. Okay, because I have two different roots are there. This is also going to be, and I have one more thing, un star I can write it. Okay, that is going to become like r pi equal to some Pn by r power n plus 1 into Pn of cos phi is going to come. So two things are there. Okay, so therefore your u is going to become like you can write that u is equal to, you are going to put the summation. Therefore, you are going to get summation n equal to 1 to infinity an into r power n into Pn of cos phi is one solution. Another one, okay, you are going to get something like summation n equal to 1 to infinity. Okay, so Bn into actually plus you can put. Okay, so one you are going to get is like interior problem, another you are going to get like a exterior problem. Okay, so here what I am going to do is that, so you have a sphere. Okay, you have a sphere. You have a sphere. So in this case, I am going to solve it into two things. Okay, one is called interior problem, another is called exterior problem. So if it is my sphere is like this. Okay, I have my radius r. Okay, so inside that I have one problem, because this is going to become like an r power n is going to be there. So inside means what is it going to come? You can just substitute it. Your r by r. Okay, your r by r is going to be bounded. Okay, so it is r. So if we take r equal to this one, r by r is going to be less than 1 is going to come. Therefore, you are going to get your so if I substitute over here, what you are going to get is that you are going to get your problem to be bounded. Okay, because this is, if it is exceeding, this will be exponentially growing. Okay, that is not the case. Therefore, you should solve it in two cases. One is interior problem. For interior problem, you use an r power n Pn cos phi. Okay, this is for interior problem. Okay, because on the exterior, if I substitute it over here, this is going to become like the exterior side is going to become like exploding, because the term is in the denominator. Therefore, it is going to become exploding. Okay, so therefore you are not going to solve this one. So you are going to take r less than or equal to r, means you are going to take a and r power n Pn cos phi is going to be used. Okay, and for this is for r less than or equal to r, and r greater than r, you are going to use the other one, Bn by r power n plus 1 Pn into cos phi is going to come. This is going to be for the exterior problem, that r is greater than r. So this is called exterior problem. Okay. So here ans and bns, once again you know that bns are this is called Fourier Legendre series, which we have already seen one time. Fourier Legendre series, both the cases. Okay. So in this case, what you can do, once again you need to use this condition. The condition is given that you have this condition, u of r comma pi equal to f of pi is there. So you can use that u of r comma pi equal to f of pi, and then substitute that value over here. Therefore, what you are going to get is that you are going to get your f of pi from here, which is obtained. So from that you can obtain your a. Okay, an is going to become like 2n plus 1 by 2 r power n, where this 2n plus 1 by 2 r, this 2n plus 1 by 2 r is coming because we know this condition, Pn into Pm is going to be integral Pn to Pm minus 1 to 1 is going to become like 0 if n is not equal to m. Okay, and equal to 2 by 2n plus 1, 2 by 2n plus 1 if n equal to m. This we know. Okay, so the same thing we are using here. So that's the reason you are getting 2n plus 1 by 2 r power n. R power n is coming because you have this r power n there. Okay, only this is going to become like give you that 2n plus 1 by 2 by 2n plus 1 is going to come. Therefore, this r power n will be there. So r power n is going to come in the denominator. Okay. So that's the reason you are having this one. Okay. So now, so you can see here, why I mentioned here r by r power is there. Okay. This r by r power is there. You can verify that. See, r is less than or equal to r means your r power n by r power n is less than or equal to 1 is there. Okay. If it is less than or equal to 1, this series is going to converge. Okay. If it is less than or equal to only this series is going to converge. So that's the reason we are keeping that. Okay. This is going to come because your an term there is a 1 by 2 power rn is there. Okay. 2n plus 1 by 12 by 2 power rn is there. So on the equation we have r power n. So if I substitute in the place of an, suppose if I substitute that values over here, this is going to become like r power n by r power n, and then extra terms are there, 2n plus 1 by 2 etc. is there. Okay, and then bn cos pi is there, integral is there. So in this case, what you are going to get is that this r power n by r power n, this is going to be valid only if r by r is less than or equal to 1. Okay, so if it is greater than what it is going to come, this is going to become like a greater than one number. Okay, r by r power r greater than r, it is going to be a bigger number, and this is a bounded one. So therefore, this is going to be diverge. This will diverge. Okay, that's the reason we are not considering this this case like x power n plus 1 or a by r power n plus 1 case. I'm not considering because in that case this is going to exclude. Okay, so that's the reason we are considering. So same way for exterior problem you need to consider the other way. Okay, for exterior problem you need to consider the other way. So if r by r is greater than r, so in this case r by r is going to be less than. Okay, so therefore here you can see that again bn is going to be calculated from the same way. R power n plus 1 is going to come. So you are going to get r power n plus 1 will come here in the place of bn. Okay, therefore you can see that this is going to become like less than 1. R power n by r n plus 1 is going to become less than 1. Therefore this series is going to converge. Okay, so that's the reason we are splitting it into two problems. One is called interior problem, another is exterior problem. So interior problem, this is going to be bounded, it is going to be a solution. Exterior problem, so for the exterior problem means r greater than r, this is going to be unbounded because this is going to exist. That's the reason we are splitting it into interior problem and exterior problem. So there are some exercise problem. So the exercise problem is that you can take a sphere, okay, spherical capacitor. Okay, in the electrical engineering they have this potential problem. They used to solve it using the potential Laplace potential, okay, or electric potential. They used to solve it using this Laplace equation only. So for that Laplace equation, what you can do is that you can take this spherical coordinate problem and then you can solve it. Okay, so in this case, what we are solving is we are finding the potential inside and outside spherical capacitor consisting of two metal hemispheres. Okay, there is a two metal hemisphere. One is on the top one and bottom one is there. So two metal hemisphere. This line, okay, this like put it the red color. This line is small gap is there. Okay, so apart from it consists of two metal hemisphere splitted by a small slit. Okay, the slit is let's say like 30 centimeter. Okay, 30 centimeter means it is little big only. So 30 centimeters separated by a small slit which is insulated. Okay, so this part is insulated. Okay, this part is insulated, and then we need to solve this problem. So if the upper hemisphere is, so in this upper hemisphere I'm keeping it like 110 volt I'm keeping. Okay, volt I'm keeping. Okay, and the lower is grounded. The lower part is grounded. Then what you need to do is that you need to solve this problem. Okay, so here what is given, you have given the f of u of r comma pi is given to you. You need to solve the problem. Okay, so you can use this. You can just check the solution for this problem in basic book. It will be there. Okay, I'm just creating it as an exercise too. And that's all for today's class. So almost we covered all the things which is in your syllabus. So if you have any questions, you can ask me. Okay, whichever topic you want to discuss, maybe another 5 minutes you can. If you want to have any clarity, I can just give you the clarity of the proof or clarity of the problem.